take a look at this question. So as we mentioned, we're trying to find the mass of octane when it is completely burned during the heating of 20 liters of aqueous ethylene glycol automobile coolant from -10 to 7 degrees. So the volumetric heat capacity of aqueous ethylene glycol is 3.7 kilojoules per liter Celsius. All right, so we started over here. So we said we wanted to find the mass of the octane. All right, so we said that mass is equal to your moles times your molar mass. So that part we got. And we also mentioned that your moles is equal to your delta H of the reaction over your H, your molar enthalpy. So this is why here, instead of our N, we swapped out for delta H over H. So we got there. All right, then we mentioned how delta H is then equal to your negative Q, which also means that equals to your negative MC delta T, right? So over here, we swapped our Q, our delta H, into negative Q, then into our negative MC delta T. So we got to this step, all right? Now, the next part, now the most important thing to understand here is that your MC delta T, that's regarding your surrounding, right? The surrounding in this case is going to be your ethylene glycol. We cannot mix that up with our mass of octane because, again, that was a common mistake that student made on their lab assessment, mixing up the masses to use. All right, that's why I have the number EG here. Once I hit this step, I can just start filling in numbers that I know. All right, first of all, the mass of EG, ethylene glycol, we know that from the question, 20 liters. All right, the C of ethylene glycol, it's given in the question, 3.7 kilojoules per liter Celsius. All right, so we have 3.7 kilojoules per liter Celsius. All right, our delta T of the ethylene glycol, again, in the question, it states it's from -10 to 70 degrees. All right, so you do 70 minus your -10, you get 80 degrees Celsius. That's your change in T, delta T. All right, we have that number here. All right, so that takes care of 1, 2, 3. All right, we need the molar mass of octane. We can calculate that. All right, you can calculate that by yourself, but octane is just, C8H18. So you do 12.01 times 8 plus your 16 hydrogen. So once you add that up, you will get an answer of 114.26 grams per mole. So now here's a big problem. The molar enthalpy of octane, we don't know that. How can we find that out? So remember now, this molar enthalpy is going to be of the reaction, right? We have the surrounding, we don't have the reaction. So this is where our molar enthalpy of formation is going to come in. Because right now, for this reaction, we don't know the delta H. So we have to calculate the delta H. So whenever your delta H is missing, most likely you're going to have to calculate it. All right? So in order to do that, remember that your delta H is your product minus your reactant. All right? So here's our products. We have 16 carbon dioxide, 18 waters. Then we have we have 2 octanes with 25 oxygens. All right? So we set up our equation. So we have delta H is 18 times our H2O plus 16 times our carbon dioxide. Subtract that from your reactants, 2 times your octane minus 25 times your oxygen. No, that's a 0. That's an O, not a 0. All right. Now, what you're going to do next is, okay, so your H2O. Now, H2O, we really got to watch out because H2O can exist as a liquid or a gas. In this question, it states gas. So if we go to our data booklet and we find water, which is here, you'll see that it's going to be water liquid, aka, water liquid, and also water vapor. The numbers are different. So we have to make sure that we use the number for the right state. So since it was water vapor, we're going to say negative 241.8 for our molar enthalpy of formation. Wait, was it? Oh, it was gas. Wait, what did I say? Negative 241.8. Okay, yeah, gas. So negative 241.8. All right, cool. So next up. So now I plug in my numbers. Plug. Okay, big equation. I skipped my units because it's too big. And we have to remember that when you have an element, it will be 0. Because again, elements already exist. You don't form elements. They just exist in nature. All right? So once you find that, so you have your delta H. Overall, it's going to be negative 10,148.2 kilojoules. All right. That means our delta H here is going to be negative 10,148.2 kilojoules. We're not going to worry about sig digs until the very, very end. All right. And again, try not to round your numbers. And I just realized I do not have a calculator at home. Okay, next. So our next step would then be to find our H. All right, to find our H, remember that, again, delta H is equal to your N times your H, which means delta H over your N is going to give you your H, right? So now you're like, where does the N come from? Well, the molar coefficient. So we're going to say the molar enthalpy of combustion when it comes to octane is going to be negative 10,148.2 kilojoule divided by that 2 mole, meaning your H of octane would finally then be so 10,148.2 divided by 2, 5,000. So 5,074.1 kilojoule per mole. All right. So now we have all our numbers. So H of octane is equal to negative 5074.1 kilojoule per mole. All right. So now we're going to be plugging all the numbers we have here into that formula that we derived. Okay, so we have our mass of octane. That is equal to negative the mass of ethylene glycol, which in this case is more volume, but it's whatever. We have 20 liters. All right, times the C of the ethylene glycol, which was 3.7 kilojoule per liter Celsius. All right, times your delta T, which is 80 degrees Celsius, times your molar mass of octane, which was 114.26 grams per mole, all of that divided by your molar enthalpy of octane for combustion, which was negative 5074.1 kilojoule per mole. All right, now we want to make sure that our units balance out. All right, so I'm just gonna look at the top for now. So 20 liter here, cancel. All right, we have Celsius bottom, Celsius top, cancel. All right, and then nothing else cancels for now. So we'll leave it. All right, so up top, my numbers, if I add them together, I have negative 20 times 3.7 times 80 and times 114.26. which ends up giving me big number. So my mass of octane is going to be equal to negative 67 6419.2, and I have kilojoule, gram, all over mole. Those do not cancel out yet. All of that divides negative 50,074.1 kilojoule per mole. So notice how we have here kilojoule divided by kilojoule, mole at the bottom divided by mole at the bottom. So those will cancel out. So then you will see that your final answer will then end up in grams, all right? So that means our units will match because mass of octane has to be in grams. If you somehow end up with, let's say, degrees Celsius, that means you messed up somewhere. You have to go back, see where did you not cancel out the Celsius, all right? So now, final step. So you did that number divided by negative 5074.1, you will get around 133.3 grams. All right, now here's a question. Is that our final answer? Not quite. I have 4 digits here. If we go up, the numbers we used, the smallest digit was 2 significant digits. So we have to make sure that this is to the 2 significant digits. So we're going to say, again, to do 2 sig digs, we're going to move this decimal point 2 times. So if I move it 2 times, that'll be what? 1.3 times 10 to the power of the twice that I moved it, and then grams. So that's going to be our final answer. All right, looking over it again. The hard part was realizing that this H of octane has to be from the delta H of the reaction. Again, the H here refers to the combustion of octane. All right, because they want the mass of octane when it is completely burned, right, in this reaction here. That's why we had to find a delta H, because that was our combustion enthalpy overall for 2 moles of octane, 25 oxygens, 16 carbons, and 18 H2Os. All right. So now the next question is about the same. All right. So I will erase this part. All right, so what we got? So we have example 2. The respiration of glucose is a chemically similar to a complete combustion reaction produces liquid water. That's a key, liquid water. All right. Calculate the change in temperature of a body composed of 65 grams of water during the respiration of 18.5 grams of glucose. All right, so when you have these questions, we got to make our formula again. But notice how the delta H was not given. Right, we have to calculate that. That's from here, just so we know. We'll get there soon. All right, so we have to get the delta H of the general reaction. So we first start by writing out our reaction. And again, it says liquid water. So we have to make sure that our water's in the liquid state. Again, your delta H is going to be your product minus your reactant. All right. So our product, we have 6 H2O. So 6 mole H2O right here. All right. We have 6 CO2. So we got 6 mole CO2. That's our products. That's going to subtracted by our 1 mole of glucose, 1 mole glucose. And again, 6 oxygen, 6 mole oxygen. So now, again, we go to our data booklet. Okay, so we first find H2O. Again, H2O, there's 2 phases. We're using liquid. So we go to our data booklet. H2O liquid. I can't highlight, but it's right there. All right, negative 285.8. So we come back, we say 6 mole times our negative 285.8. Then we have our CO2. So let's find CO2, carbon dioxide. This is all alphabetic. So we go to C. What is going on? C, carbon dioxide. So you will see that it is negative 393.5. So we have negative 393.5. All right, minus what's in our reactant? We have glucose. All right, so glucose, dang, G glucose. Okay, so now we made the assumption that here we had what, solid or aqueous glucose? Oh no, we had, why is it gas glucose? What am I doing? This is supposed to be solid. Okay, the solid glucose, I don't know why it's a gas, that's weird. Solid glucose is negative 1273.3. All right, so we have negative 1273.3. And again, oxygen is an element. Elements will always have no enthalpy of formation because, again, you can't form an element. Elements already exist. All right, so now it's just math time. Now, remember that all these numbers, I did not write the units in, but these are all kilojoule per mole. All right, kilojoule per mole. So when you multiply, look, mole top, mole bottom, mole top, mole bottom. Same thing here. Mole top, mole bottom, mole top, mole bottom. That means all you're going to be left with is just the kilojoule. All right, so overall, then you get this number minus that number. And overall, your final answer for the kilojoules of the reaction, the respiration of glucose, is going to be negative 2802.5 kilojoules. So we put that over here. All right, so now let's make our little formula. So the question is asking us to calculate the change in temperature. Which of our equations, or formulas should I call it, will include a change of temperature? Oh, Q equals mc delta T. Okay, let's do that. So we have Q equals mc delta T. All right, now, again, the mc delta T, what's changing? 65 grams of water. All right, so we have to make sure that when we do the mc delta T, we're doing the water mass, not the glucose mass, right? So something on a test that might help you is if you write mass of H2O, C of H2O, and then delta T of, well, you can write H2O if you want, but it's kind of pointless. It's whatever. Okay, delta T. All right. So then, since we want to isolate for our delta T, that means we got to divide it by our M and C on both sides. All right. That means then we have Q equals mass of your H2O divided by C of your H2O, which equals, again, cancel, equals your delta T. And now here's the problem. We don't know our Q. We don't have a Q. We don't have the heat released. So to find that out, we got to swap this number out for something that we have. Okay, remember that your Q equals or negative Q equals delta H, right? That means to get Q, if I multiply both sides by -1, I get Q is equal to my negative delta H. So that means, if I just copy this, and I just paste, we can swap out my Q for negative delta H. All right, now, one thing we gotta watch out is that this delta H is not the one that we have here. All right, why that is because this delta H refers to when you have 1 mole of glucose with 6 moles of oxygen with 6 moles of carbon dioxide and 6 moles of H2O. If you look here, we have 18.5 grams of glucose. Now, if you do your calculations, you will find that 18.5 grams of glucose is not 1 mole of glucose. All right, it's a lot less. So we cannot straight up use this number. That means we have to go down deeper. All right, so delta H is also equal to our NH, right? So I'm going to copy again, paste. We're going to say that This would then equal to your N of, what was it, glucose, times your H of glucose. All right? Because the delta H talks about the reaction itself, which is why we include glucose, because that's what we want. All right? So we can stop right there for our formula. So right now, we know the mass of water. It's given in the question, 65 kilograms. All right? We know the C of H2O, 4.19 kilojoule divided by kilogram Celsius. We don't know the moles of glucose yet, and we don't know the molar enthalpy of not combustion, but respiration, I guess you can call it, respiration for glucose. So we gotta find these two numbers. The moles is pretty easy. Well, because moles of glucose would just be your mass divided by your molar mass, right? So the mass of your glucose is 18.5 grams. So 18.5 grams. And then your molar mass, I think I had it somewhere here. Okay, we don't. I gotta calculate it. Okay, never mind. So molar mass, if I do it real quick, so glucose, so that's 6 times 12.01. And then 12 times 1.01, and then 6 times 16. So that adds together to give you, computer, hello? Okay. 6 times 12.01 plus 12 times 1.01 plus 6 times 16. So it's 180.18 grams per mole. All right. So that means that number at the bottom is 180.18 grams per mole. So that means the number of moles you have is then going to be, so 18.5 divided by 180.18. It's about 0.103, about 0.103 mole. All right. So now our final number that we got to find, because now we have this, our mole, is our molar enthalpy of respiration for glucose. To find that, that's where we use this number that we calculated. All right, now that's only your delta H. We want molar enthalpy. All right, you got to bring in the coefficient, right? Because again, the coefficient says 1 mole. For 1 mole, it will produce negative 2802.5 kilojoules. So that means our H of glue would then be negative 2802.5 kilojoule divided by your mole, or 1 mole, should I say, which should just give you the same number. So negative 2802.5 kilojoule per mole. Okay. So now we have all our numbers. Okay, it's a lot of math though. Let's make it smaller. We'll put it here. So our final step, I'm gonna steal this, copy. All we're gonna do is we're gonna fill in numbers. Boom. Okay. So let's see. Our N of glucose was 0.103 mole. Our H of glucose was negative 2802.5 kilojoule per mole. All right. All over the mass of your H2O, which was 65 kilograms, and our C, which was 3.1, hold on, 4.19 kilojoule per kilogram Celsius. All right, so we're gonna see if my units balance out. All right, first of all, if I look at the top, I have a mole, cancel. At the bottom, I have a kg, cancel. All right, I'll leave the rest just for now. So that's gonna give me at the top 0 point da 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 times negative 2802.5. What am I doing? So at the top, it's about negative 287, well, 288. I'll say 287.7 kilojoule. And at the bottom, we have 65 times 4.19, which was 272.3 or 0.4. And our units at the bottom was kilojoule per Celsius. All right, so now I'm gonna do something a little weird. All right, so first of all, 272.4 kilojoule per Celsius is the same thing as saying 272.4 kilojoule over Celsius. All right, it's the same thing. All right, now remember that fraction means division, right? So when you divide a fraction, it's the same thing as multiplying by the opposite. So if I flip these two, it's going to become degrees Celsius over 272.4 kilojoules. All right, what I'm trying to get at is that this is the same thing as saying negative 287.7 kilojoule times Celsius over 272.4 kilojoule. So you will see that if I move this up a little bit, you will see that, and I can put up over 1 kilojoule cancel out. So all we're left with is our Celsius, which is exactly what we want, because again, our end goal was to calculate the change in temperature. We have the right units here. That means we did things right. Where am I? All right, cool. I'm gonna erase this. So what that means is that for my final step, all I gotta do is just divide those two numbers. All right, so that will finally get me to oh wait, the answer is not supposed to be negative. I'm supposed, where did I miss a negative somewhere? Okay, hold on. Where did I mess up my negative? Negative MC delta T. So negative. Oh, this would be a negative here. Negative. So since we have a negative, well, not here, but since there's a negative here, so basically a negative here, this becomes a positive. Oops. So this is positive. All right. So we missed that negative when I copied over. There was a negative here because we had a negative delta H, right? Equals your Q. Okay, so then again, final step, all that divided by the bottom. And we will get around 1.06 grams. All right, so again, we need our sig digs. Sig digs, we have 2 sig digs. So it's gonna be 1.1, what am I saying, grams, Celsius as our final answer. All right, so again, quick review because it was a bunch of stuff. All right, now honestly, you could have started here and then be like, I need my H, so you had to do all that. But I just found my delta H first because why not? So again, when your delta H is not given, most of the time you're gonna have to find it, right? So to find it, you can just use your molar enthalpy of formation. So we first started by product minus our reactant. All right, so we calculated, we went down all that step, we got to negative 202.5 kilojoules. So we found the enthalpy of the general reaction for the respiration of glucose. All right, then we're like, okay, since we want to find delta T, we need a formula with delta T inside. So we said, okay, well, Q equals MC delta T has a delta T inside, so we're going to use that, right? So in order to isolate for delta T, we said we're going to move the M and we're going to move the C. So we got that right here. Now, since we do not know our Q, we have to swap it over to something else. So since, again, negative Q equals delta H, that means our Q is equal to our negative delta H. They are always inversely related. All right, so we swapped it over for negative delta H. All right, now delta H is the same thing as our N times H. I do not know where I wrote that, but I wrote that somewhere. Whatever. So since delta H is the same thing as N times H, we're going to say that's going to be our N times our H. And since we're worried about glucose, and we have the mass of glucose, we're going to say N times the molar enthalpy of glucose in the respiration reaction. All right, so we don't have two numbers. We do not have the moles, and we do not have the molar enthalpy, right? So to calculate the moles, that's not hard, right? That's just mass over molar mass. So the mass of the glucose was given to us in the question, 18.5. So we just use that divided by our molar mass, 0.103. The harder part might be the molar enthalpy of respiration for the glucose. So that, again, we had to use our delta H here and divided by however many moles there are present in the reaction itself, in the balanced equation, so which was 1. So our number ended up being the same, which is fine. So we got negative 2802.5 kilojoules per mole. So final step, get in all those numbers. All right, now it's just calculator. But the big thing is making sure our units canceled out. All right, so if your units doesn't end up canceling out, that's when you know for sure you messed up somewhere. So when you do your calculations for like written response, especially ones of this difficulty, I strongly encourage you guys to put in your units. So then once you like cancel thing out, you will see that your answer is either right or wrong given based on the units. All right, like example, one thing I see really common is, let's say if you have, I don't know, let's say 2 grams, well, let's say 2 mole divided by 2 grams per mole. All right, and then somebody would cancel this and that out. That doesn't work, right? Because 2 mole divided by 2 grams per mole, again, that means 2 grams per mole, right? That means when you have to multiply by the inverse. So if I put this over 1, that'd be mole over 2 gram. That gives you basically 2 mole squared over 2 grams. That does not cancel out the mole. That just makes mole squared. So we have to make sure that it's actually canceling out. You can't divide by a denominator and then cancel that out. No. If it was something like this, 2 mole per gram, then yes, those cancel out. But yeah, so we really got to watch our units. All right, so again, any questions, email me. I should respond pretty quick. But yeah, that's about it. And then the rest won't be on the quiz. But you're definitely going to want to know how to do this question or this type of question, because there is one written response on that level. And then, try number 8. Number 8 is a good practice. All right, this page won't be on the quiz now. So like this stuff, try this one. Pretty good. All right, okay. Peace out. How do I stop this?